We are Group 49, the water majors, made up of Madison, Joe, Riley, and Selah.
Our primary design goal was to build a filter that was quick and effective. We decided to order the largest diameter pipe to ensure a greater flow rate, and charcoal and the fine sand because we thought this media would be effective in filtering the red dye out. We also chose cheesecloth and cotton balls to absorb some of the red dye, and a styrofoam cup to catch the filtered water.
In our first design, we separated layers of two different media and thick cheesecloth in between the media inside of the pipe. We also placed cotton balls toward the bottom of the filter with hopes of it absorbing some of the dye. This design was not freestanding. This design had a low flow rate because of how absorbent the cheesecloth was. Also, our sample turned out to have a darker hue than the solution that we put into the filter.
The major problems with our design was that our cheesecloth was too absorbent and did not effectively pull the dye from the sample. We did not initially clean the charcoal sample, which caused the first filtration to produce darker liquid than what was put into the filter. We did not use enough of the media in this design because we were trying to use as little material as possible. One of the major problems with this design was that our filter was not freestanding, therefore it didn't fit the criteria.
After testing the original design, we decided to make some changes in hopes of making our filter more effective. We exchanged the pipe for the top half of a plastic water bottle and the styrofoam cup for the bottom half of the exact same water bottle. This was cost effective as we now only used one water bottle, which was cheaper than the price of the pipe and styrofoam cup. After observing that the fine sand seemed to not be doing very much in terms of absorbing the dye, we decided to get rid of it completely and went with just the charcoal. Finally, we realized that the paper towels and cotton balls were too absorbent, only slowing the flow rate while not removing the dye from the solution, so we decided to get rid of them as well.
In our final design, we used the water bottle filled with a large amount of charcoal. We placed a small piece of cheesecloth at the bottom of the water bottle to keep the charcoal from falling through the filter. We poked small holes in the cap and screwed it on the bottom of the filter to allow water to pass through while still allowing the solution to stay in the media for a longer amount of time. In the diagram, we show the top half of the water bottle with the charcoal on the bottom as the water flows through, with the cheesecloth holding the charcoal in while the bottom half of the water bottle catches the water.
After running our tests with our final design, we found that the flow rate compared to the original design were much greater and our absorbance rate was also much better. Using the professional spectrophotometer, after one of our tests, we found that we filtered out 40% of the dye.
The total price for the final design came out to be $86.50. Since every group was given $300 to spend, we feel that our design will be less expensive than most of the other groups. The highest costing material in our design was the charcoal, which accounted for 65% of our total cost.
We attempted to achieve several of the stretch goals with our filter: high flow rate, lightweight, aesthetically pleasing, single media, and recyclable.
Should we feel the need to improve upon our filter, we could use coffee filters, which are very good at removing dye. We could have taken some more time to clean our charcoal, which despite being rinsed several times was still causing the water to turn a darker shade after passing through it. And we could have simply spent more time testing other media and tweaking our design to make small improvements.